Okay, I'm ready to go. If you guys are ready. Um, my first session this conference, one of the things that did not happen this morning, that's happened at most other PUG challenges, especially in Europe, is the question is who are the people here that are first time coming to the PUG? And normally a bunch of people raise their hand. So I'm glad there's some people in here that are raising their hand. So that tells me that you don't know who I am. So and you don't get this joke. And this joke probably doesn't play well in Europe either. So I got to give you some background here. So my name is Mike Furgal. I've worked at Progress, believe it or not, first job out of college, all the way through to retirement. Retired about 2.5 years ago. Um, I worked for Gus for a lot of that time. Gus is the architect of the OpenEdge database. And then Gus worked for me for a short period of time. And Gus had retired, and I retired. So Gus is now the head groundskeeper at the Parmington Foundation. Since I'm retired, I'm the assistant to the head groundskeeper at the Parmington Foundation, and that's a joke from The Office, which is a sitcom in the U.S. I'm not sure if anybody's ever seen that one, but there was a guy that wanted to be the assistant manager, and they only let him be the assistant to the manager. So hence that's the joke. So squaring that up right away. So I worked on the database team for many, many years, decades, and again, my entire career has been at Progress. And I'm here to talk about basically what it means to be a DBA and maintain your database. And how I'm going to do this is just talk about what you should be doing on a day-to-day basis, month-to-month, quarterly, yearly, stuff like that. And this is my opinion on this. Another piece of my background is I ran the managed database team at Progress for 10 years. So at the time that I was doing that, I had a team of 22 DBAs that were managing, I can't remember now, I think it's 1,600, no, it was 160 customers and about 3,000 databases that they had to manage. So these are the things that we've learned through that experience of being a DBA for a massive set of systems that were all disparate systems. They were not all one application, but there were a variety of applications. So if we talk about daily tasks and housekeeping, ask a question anytime you want. Make a comment anytime you want. So in order to keep your OpenEdge environment running well, what should you be doing periodically or daily? You should be looking at to make sure that you have free space in the database. You don't want to run out of free space. You don't want to run out of space on the file system, which today, here's another aside. It's stunning to even have to say this today, where you can get disk drives that are 4, 5, 6 terabytes large. However, in the production OpenEdge world, it's still stunning to me that people are still running file systems that might be 200 gigabytes because they're just not getting these modern machines or getting these modern storage. Watch for long-running transactions. If you have a long-running transactions, that's going to slow things down. It's going to hold record locks that other users are probably going to have to wait for if they have these record locks. And I'll talk about how to find your long-running transactions. Monitor the before image file size. If you have a long-running transaction, most likely your before image file is going to grow. That's not a good thing. And if you run out of space in your for the before image file, your database will not recover. You are now going into your disaster recovery plan and having to restore a database. So it's a very key thing to make sure you're monitoring the BI growth. Watch for runaway processes. This happens all the time, especially in a character environment. Somebody clicks X on the terminal emulator, and sometimes that underscore progress process will spin, and you won't even know it. You do a PS or a top, and you see a process that's been chewing up CPU for the last 3 days, and it's just completely tying a CPU up. So you got to look for those. Look at the log file for errors. Verify that after imaging, extent switches are happening, and then verify that your backups are successful. So how do you look for long-running transactions? Here's 2 ways you can do it. One is using the virtual system tables. So there's a virtual system table called _trans. It is a completely filled out table. So if you just looked at that table, you'd have a bunch of rows that have a bunch of question marks in it. And the question marks in it are slots for transactions that are not active at the moment. So you've got to filter those out. So say where transnum does not equal question mark, and that'll get rid of all the ones that are the placeholders. And then you can display a lot of stuff. You can display the whole underscore trans table, or you can just display the transaction duration, and that's the time in seconds. If you don't have a 4GL compiler license, which a lot of people don't, then you have another option. You can use Promon. You can go into R&D, status displays, process clients, 3 active transactions, and that'll give you basically the same table. That'll tell you what that transaction is, who has it, what time they logged in, and what time that transaction started. So if you have a long-running transaction, you have to define what is a long-running transaction. Is a long-running transaction something that's running for 10 minutes, running for 2 minutes, running for 30 minutes? On the managed database team, we had triggers that fired for any transaction that ran longer for 30 minutes, and an email would get fired to us and the team to say, okay, this thing's been going on for 30 minutes. Is it actually doing anything, or is it a screen that people have the scoping wrong across UI, and somebody's got their mail client up in front of it, and then they forgot about it, and they launched the application again. So, very common thing.
If I got 3 databases connected, and I do just in the 4GL do transactional and I run them, and in that transaction I run this code, does it show up in all that?
No. The question is, you're connected to 3 databases, and you have a transaction that's you're connected to 3 databases, you have a transaction that's in a single database doing long running. Can I look in all 3 of them and see that transaction in all 3? No, you're going to see that transaction only in the one that's active, unless you have that transaction spans 2 databases. So if you have reading table in database 1, reading table in database 2, updating them both and then hung, then both of those will have the VST or a Promon entry showing that you have that transaction active. The third one would have nothing.
Yeah, what's the assumption? You know what it is?
Yeah.
Assumptions.
Yeah.
The entries in the VST tables, for example here in trans, is it always generated with a for each, or is it always statically there, or from where do the entries in this table come? Is it like a normal database?
So the question is, this is a generic VST question. So the question is, and VST stands for Virtual System Table, is where's this data coming from? And this data is coming from memory. Most of these tables are 1-row tables. Like you have an underscore activity summary table, which relates clearly to Promon R&D to activity 1 summary, and it has all those fields in that. So that's a 1-field table. That's a 1-row table, so you could just do a find. This all comes from memory. None of this is stored in disk, so none of this is retained.
And in the moment of when you execute the find, then it's going to be generated.
Correct. The moment that you execute the find, it's going to read shared memory, populate the table, and display it like it's a 4GL table, even though it's not.
Yeah, so the formatting is done on demand.
Yes.
But the data is there permanently.
Yes. Thank you.
Okay, so look at the log file. Log file is going to have a lot of information in it. You're going to have log in, log out, a lot of information. It used to be not so populated, and now more and more things are putting more and more stuff in the log file. So you have a lot of information there. And there's some things that are not really important that you can probably ignore. For example, you have TCP IP write errors, error no 32, error no 113. There's a whole bunch of these. These most likely are clients that have clicked X, did not log out of the application, and they were in the middle of something. They're asking the database server to go get me a record, and it was sending the record back, and the client's gone. Nothing really to worry about. So there's a lot of times you'll see a lot of networking errors, and for the most part, those tend to be transient and can be ignored. But there's other things that could be scary that you should do some investigation in. The system error, anytime there's a system error, that should get your ears a little bit perked up. These are not that bad because you look at the file, and the file starts with DBI. The DBI is the temp table database. So in this case, these are probably clients that are running client server talking to the the database server, it's having a problem writing to the temp table database on that Windows client machine, and it had an error, and the error has to be written somewhere. The only place it's going to write is to the database log. Temp table doesn't have a database log, so the only place it can write it to is a connected database that is connected to. So hence you have these DBI errors that look bad, but they're not on the database server. They're, unless it's the temp tables on the database server, but they're not really part of your production database. These temp tables are transient tables, but it's worth noting, if you have a lot of these, that you might have a Windows machine that has a disk problem. Then you might want to go and take a look at that. Or a Windows machine that ran out of disk. Another one would be trying to write and it says no space available for the DBI, probably out of disk space. So they might need some investigation, but it's probably it's not as big of a concern on your database server. However, there's things that you shouldn't ignore. You get a core file. This means that progress has run into a bug, most likely. You got to be able to figure that out. Is it happening all the time? Do you need to recompile our code? Sometimes that resolves the issues. Anytime there's a system error outside of this DBI stuff, you should be paying attention to that and being aware of it and seeing if you can get to the root cause of it by Googling and looking at knowledge bases and stuff like that. And obviously, getting to the latest version of OpenEdge that likely fixes some of the stuff and also introduces more. Backups are successful. So did the backup complete? Did you run out of disk space on your backup? Did you have an extent switch prevent your backup from running? And this is what an extent switch problem looks like. On the screen for backup, you'll get switch to new extent failed, backup terminated due to errors. So yeah, the backup completed, and if you're not checking the error status, and even if you are checking the error status, I'm not going to guarantee that the error status is going to be correct. You should be looking for these types of things in the output file. And just put a little mailer on it. Say, did it successfully complete? And if it didn't, send yourself email with this log file. In the log file, you'll see this. In the database log file, it'll say, can't switch to after extent this, and it'll tell you why, and please mark it as empty and move on in order to get the backup to work. And now I'm going to talk about storage areas. I just came from Dimitri's talk. Who was in Dimitri's talk? A handful of people. So Dimitri did a really good talk about storage areas, so I'm not going to go in really in depth. One thing he didn't mention right at the beginning, he assumed everybody knew what the RM chain was. And the RM chain is the chain of blocks that have space in it that can take another record, or a record could be expanded and there's room for it to expand. The free chain is a chain of free blocks in the database. So if you're creating a record in a table for the first time, it's going to go look on the free chain to go find a block to go put that record in. That block then moves to the RM chain. Next record gets created, and it's going to look on the RM chain to see, is there a block that has room? If yes, put it there. If no, go get another free block. High watermark is the highest block in a storage area that's in use. And an empty block is any blocks above the high watermark that are in that storage area. So it looks like this. You have extent header, object block, and then you have table blocks and index blocks if you have tables and indexes in the same storage area. Don't recommend that, but I'm just showing this for purposes here. At some point, you have a high watermark. Any empty block below the high watermark is called a free block. Any empty block above the high watermark is an empty block. So you have a storage area that looks like this. 3 extents, that's what we call these. The first extent's full. The second extent is almost full, and it has a high watermark where you have empty blocks above it. And the third extent is completely unused, and in this case, it's variable. And the second storage area, another example where the high watermark is. And over time, if this goes unmonitored, you start filling things up, and then the high watermark ends up being in that variable extent. And if it's in that variable extent, then your file starts growing. And it used to be, decades ago, that growing a file was really expensive for performance. It's not that bad anymore. But if you're managing many databases, or you don't want to be looking at disk space all the time, you don't want to be growing the the files on the file system where the database is, because then you have to worry about disk space. So if you can keep the diagram looking like this, where you have free space in the database, then you never have to worry about disk space on the system itself. So here's some recommendations. Each storage area should have no more than 10 files or extents in it. 5 would be better. The reason for this is every process that connects to shared memory, be it a direct client or a server client or an app server, has to open every single file, and they open the file twice. They open it once for a buffered file handler and once for an unbuffered file handler. So when they write to the file, they have the choice of writing to the buffer pool, the OS buffer pool, or writing directly to disk. Each extent should be no larger than and ... because as soon as I say it, it's going to be obsolete. So I'm trying to come up with some guidelines here. So it depends on the speed of your disk. It depends on the speed of your CPU. Here's a guideline, and I don't know if this is good. Can you copy the extent in 15 minutes or 30 minutes? If you can, maybe that's the right extent size. If it takes you 3 hours to copy an extent, maybe that file's too big. There is a 1 terabyte limit. I know this because I had databases that I didn't really care too much about, and we've hit the limit several times. But please, please, please don't have a single variable extent that's large. If you have a small storage area that's 100 megabytes or even 3 gigabytes, sure, have a single variable storage, or if you can deal with the variable aspect of it, have a single file for that. But if you end up having these very large extents for a table for an area that is, say, maybe it's a 700 gigabyte storage area. That's a reasonable size storage area, and you have a 500 gigabyte file. Well, you're not kind of adhering to the 5 extents. You have 2 extents, and the problem with this is if something goes wrong, now we're operating on a large piece of data as opposed to a smaller piece of data. If you can operate on something small, everything's going to go faster. Yes?
What you're saying at point one is that you should increase the extent size if the table is large, or the area is large.
If the area is large, you should have fewer larger extents, but not super large, right? So this is why I can't answer the question. Extent should be no larger than. There's no answer to it. Every environment is different. I'm doing a talk tomorrow about problems that I've encountered and how I solved them, and you're going to see one of the problems I encountered had to do with having a very large file, and we ran out of time trying to deal with it because we couldn't deal with it because the file was too large. Gus, you want to add?
I just wanted to say that what you should take into consideration is how hard is it to manage when you have really big files. Not just the extents, but your backup files too. If you have a 100 gigabyte file, that's hard to work with.
Right.
If you need to move it someplace or make a copy of it for some reason.
Yeah. So just to repeat that, Gus's point is large files are hard to manage. It's not just the database files, but the backup file. It's having a 100 gigabyte, 500 gigabyte backup file, just copying that over the network, if you needed to copy over the network, is hard. If you had several smaller files, you could parallelize copying them over the network.
What happens if you have just one table in this extent and this is more than 500 gigabytes?
If you have just one table and it's, say the second part about that?
In one extent, and it's more than 500 gigabytes.
So the question is, what if you have one table in one extent and it's more than 500 gigabytes? A table is assigned to a storage area. Storage area is made up of extents or files. So that one table can cross, since it's in a single storage area, can cross multiple files. So it's not that big of a deal. So you could have 100 gigabyte extents and have 5 of them. So it's structured that way. So you're not limited to the table size for your extent size.
Yeah, so you could have 10, 50 gigabyte files.
Okay.
This gets religious. we should have a session just on this and have Tom sitting there and me sitting here, and we'll just battle it out. Weekly tasks. So those were your daily tasks. Go ahead.
Is there also a recommendation of like maximum number of areas?
So, very good question. Is there a recommendation for maximum number of areas? Sure, I'll recommend something. And again, it comes into, I'm going to say something, and as soon as I say it, 10 years from now, they're going to be saying, well, Mike said this, and well, things have changed in 10 years. A lot of people that we were doing management for did not own the schema of the database. They were end users of an application partner. They defined the schema. They defined the storage area layout, so they were locked into it. However, if you have the ability, here's my recommendation. Make the storage area as large as you're willing to do operations on it. So as Gus says, dealing with a 100 gigabyte file or a 500 gigabyte file is hard. So have a storage area. And if that storage area is 500 gigabytes, well, that's hard. Make the storage area 100 gigabytes if you can. Now, if you've got a 500 gigabyte table, you're locked. You have no choice. You have to make that into a single storage area. But if you have two 500 gigabyte tables, don't put them in the same storage area. Put them in their own. So you want to kind of have a size idea of your storage area. A lot of application partners like to lump their objects together. We're going to put all of our transactional data in this storage area. We're going to put all of our historical data in the storage area. We want to put all of our customer or all of our account AP stuff in the storage area. You don't need to do that. It makes them feel good, but it has no effect on the administration of the database whatsoever. You're better off doing it by size. Big tables in their own storage area. Next grouping of tables, get them to be about the same size. Next grouping of tables, and then have a catch-all for all the small ones. This gets more religion, so we could talk about I could stop here and we could just talk about this the whole rest of this session. So weekly tasks, not much. I had to say after imaging at some point. So archive after image files. What's that mean? I'll talk about after imaging and refresh test and training databases. We saw this a lot in our world that. People would do weekly refreshes of their lower environments. So they have their production environment, then they have their lower environment where they're doing testing or they're doing some development and they're making schema changes and stuff like that, and they want those refreshed. And some people were on demand refreshing them. A lot of people were it's just part of our weekly task is to refresh those lower environments. But let's talk about after imaging. Oh, Gus has some comment.
No, I have a question.
To me?
Yeah, how do you know how much after image data you're generating?
Well, let's talk about after imaging first, and then we can talk about that. So, everybody know what after imaging is? Anybody not know? Who's running after imaging? Everybody's hand go up. So most everybody is. So I'm just going to go quick. Point in time recovery, not turned on by default. The last good backup and after imaging files restore you to point of failure. And it can be used to create a warm standby provided that you're licensed for it. Here's how it works. You have Monday. I didn't need to realize these were going to build. So in the typical scenario, you're only backing up and you have an issue that happens at 3 o'clock on Thursday, and you go and have to do something because something horrible happened. You go and hope that your Thursday backup is good, and you lose the data from midnight when you kicked off that backup to 3 p.m. Friday. Not the best thing. That's not really a production environment. So now after imaging has this. The green line is, and this is very simplistic. It's assuming one after image file per day, but I'm just doing this for just to describe it. So you have this situation. Same thing happens. You can restore Thursday's backup. Hope it's good, and then you can roll forward the after image file forward to bring you up to the point and crash. At that point, crash recovery will take over. Any open transactions will be undone, and you've not really lost anything, and your database has integrity. What happens if backup 4 is bad? After imaging can cross the backup boundary It's a very key thing. I hear some people didn't think that they could do that. That's a fact. So if your backup 4 turns out to be bad, you can't restore it for whatever reason, you could restore backup 3 and then roll forward AI file 3, then roll forward AI file 4 and get to your point of recovery. And here's how to do it. So this should be reviewed for most everybody that raised their hand. The one thing I want to point out on this slide that may be interesting to you is create after image extents. I like 4. I don't know why I like 4. You only really need to have 3, but 4 seems better. Gus told me if you're going to make up a number, make sure it's a power of 2, because then nobody will question you. If you said, I want 7, people are going to be like, why'd you pick 7? But you say 4, and like, yeah, that makes sense. If you're running OE replication, make 16. Make them fixed length, and make them large. Why? If you have variable length AI file with OE replication, the MTX latch is held over the time that file grows, which means you're going to have weights on MTX. And if you have a highly concurrent system, you're going to feel pain. So if you convert those to fixed length extents, then they won't grow, and the MTX latch is held for a shorter period of time. So in a highly concurrent system, you're not going to feel that pain. We found this out the hard way. So if you're running OE, who's running OE replication? Who's running variable AI extents with OE replication? So if you are running OE replication, go back and check. So that's the one thing I want to point out here.
Also comment if your replication is down, you might need or would like to have more than 16 extents.
So the risk here is if the target OE replication is down, we have to archive and not delete any of those AI files. It's great to have a variable AI file because it can grow forever, but you're going to have the performance penalty of it. So if you can live with the performance penalty, then sure, go do that. But if you can't live with the performance penalty, you're going to have to make them not 1 gig, make them 10 gig, and make them not 16, but make them 50, right?
What I said is make 250 of them.
Okay, so now we come back into so now we're going to make 250 of 1 gigabyte files, which you can make 250 10 gigabytes files. You know, they don't have to be 1 gigabyte. This is just picked it out of the air recommendation. Again, the more files you have, the more files that need to be opened by any process that has shared memory. And it's probably okay unless you have a high user count system. Because once you have more than 100,000 files opened on a Linux machine, it's likely going to start slowing down just because of the number of files open. So you want to manage this, be aware of it. Okay, Gus, ask you a question.
So how do you know how much after image data you're generating and how much space you're going to need for it?
Okay, so the question is, how can you calculate the storage requirements for after imaging? And the easy thing to do is turn it on and see how much it took, right? But then what if you calculated wrong? So the calculation here that Gus is trying to steer me towards is a good way to do this is use Promon or collect data from Promon and look at how many checkpoints you had in a period of time. Like if you could look at Promon for a 24-hour period and you could see how many checkpoints you had in 24 hours and you know what your BI cluster size is, you can do the math of BI cluster size times the number of checkpoints tells you exactly how much AI space you need for that same period of time. Is that where you wanted me to head, Gus? Thank you. Okay, Rob.
Just on the point about variable extents, in 12.1 and later, it's possible to pre-allocate space for variable extents, so they don't start out at the minimum size, they start out at a specified size and grow from there. Yeah. So that could help mitigate that growth penalty.
Right, so to repeat what Rob was going to say, and I knew this, I couldn't remember what release because I'm now retired, so I don't really pay attention to this that much anymore. On 12.1 and beyond, they put in my long-awaited feature that I was begging for the decade that I was in managing the managed database group, which is you can have a variable extent, any type of extent, that's pre-allocated to a size. So you could have a 1 gigabyte AI extent pre-allocated to a size that's variable. So if you end up having the situation where the target's down, you normally will be fine, but then if you end up growing past that 1 gigabyte on that file, that's where you're going to get that performance penalty of holding that latch over growth. I have not played with that with after imaging, so I'd be curious to see, does it maintain the fixed length size or not?
I just played with it enough to know that it doesn't go back to the minimum. It goes back to the minimum you specify.
Okay, good. Yep. So Rob did play with it, and it doesn't truncate it down to the minimum. Okay, moving on. We all good? So monthly tasks. Not much. This is what we did in our managed database group. Is we just gave a storage area report where we'll look at the system and would look at what the historical growth was, and then we'd forecast out what things would look like so we could do capacity planning. That's what we did on a monthly basis. So you can do whatever you want on a monthly basis, but I think storage area knowledge and forecasting is a useful thing, because you don't want to be surprised that all of a sudden you're running out of disk space, because then that becomes a crisis. Quarterly tasks. Run a DB analysis every quarter. Some people would say run that every month. Some people would say that run every day. But if run it periodically, I'd say run it every quarter, and keep it so you can look at how fast your tables are growing. So you can compare how many rows are in a table from 1 quarter ago to now, and then you can compare how big your indexes are, how big the storage areas are, and pay attention to how long it takes to run, because that's a pretty big clue about something. With type 2 storage area, it's really tough to know when it's time to dump and load to get better performance. There's no real good tool to tell you that. Here's a good tool that will tell you that. If it takes longer to run the DB analysis, it's time to dump and load. So trend how long it takes to run it, and then you'll get a sense of, wow, it used to only take 45 minutes. Now it's taking 3 hours. That's a sign. Gus?
What makes it take longer to run?
Fragmentation, I don't know. It's got to go read the records, right? So it's got to go find them. Was this a quiz? This one, trust me, there's about 50 more.
So with type 2 storage areas, do you still see the need of the dump and load? I mean,
so very good question. With the type 2 storage area, do you still see the need for a dump and load? And the answer is yes. And here's some guidelines. Again, just Mike's guidelines. In type 1 storage area, our experience was for highly concurrent environments, you needed the dump and load every 12 to 18 months. If you didn't do that, your performance suffered. So if you wanted to have good performance, 12 to 18 months in, you dump and load, and all of a sudden your users are going, wow, what'd you guys do over the weekend? It's much faster now. In type 2 storage area, it's tough to know. So you still have to dump and load, but it's probably more likely every 3 to 5 years. And there's no real good measurement tool to talk about it. But the next session that Gus and I are doing is about dump and load. So it's still a very, very prevalent topic that has to happen at some point. And we'll talk more about dump and load later.
Usually the fragmentation is not showing like it did in type 1.
So the comment is, in type 1, the DB analysis report was, I don't think I have it here, was very useful, because it showed record fragmentation, which is what Dimitri was talking about, where a record is spanning multiple blocks, and it also showed scatter. And scatter would be how far apart these records are relative to each other. In type 2, scatters doesn't exist, because those records are always going to be right near each other in the same table. They may not be in logical order, but they're going to be right next to each other. So scatter does not exist unless you have done a massive purge, and so there's a lot of empty space in the cluster, and then you might see some scatter, but that's such a rare case. So there's no real good reporting aspect that comes out of the box with Progress to be able to determine what the scatter looks like for type 2. So run an index rebuild or an index compact if required. And how would you know that? So table analysis is a good part of DB analysis. It tells you number of rows, size of table, fragmentation, scatter factor, which we just talked about. Scatter factor is not much use in type 2, very useful in type 1. And then it has index analysis. And I'm going to talk about the index side of this. Because the index side of this is easy. It's an easy thing to deal with. So here's just something here that's just a report from SX Enterprise type database. And you can see that they have, here's the table name over here. My pointer doesn't work. SM, SCW is the table name. And here's the three indexes on that table. In the index numbers, how many fields make up the index and how many levels are in the index. And I'll have slides to show the levels in a second. And then it talks about utilization and factor. Recommendation again. This one I'm going to stand by. This one's easy. If any index is more than 50 megabytes and you have a utilization less than 70, index compact it. That one will last forever. It doesn't matter about disk speed, doesn't matter about CPU. That's just a very good recommendation. If it's so, I have the KSMSEW one highlighted because it's 70 megabytes and it's 63% utilized. It's highlighted because that one needs to be compacted. The one above it is only 20 megabytes. Not a big deal. So don't worry about the small ones because as soon as you compact them, they're gonna get the utilization is gonna go down again because it's just you'll see in the next slide about the B tree. So here's an index. Let's just assume it's a name, single component name. The root has knowledge of the entire range for that index, A through Z, assuming it's just a name that's alphanumeric, or not just alpha. And then here's how the B tree set up. I'm going to go try to find a name that's Bob. Well, I got to go down from the root. The root knows where Bob is. It knows them all. But it says in order to go find Bob, you got to go look at this block that holds A to C because Bob's going to be in between A and C. And he goes, well, I know all the names between A and C, but I don't hold them. You're going to have to go down this block that knows A and B. And this block goes, I know all the names between A and B, but I don't hold it. You got to go to this block that's between B, E, and BU and start scanning to go find Bob. So at that point, he says, I have all the data. You just have to scan me to find Bob. You find Bob. That points you to the record, and the record contains Bob. This is a 4-level index, and all the white space is empty space. This is poor utilization. If you index compact this, now you have tighter blocks, fuller blocks, and better utilization, and look what happened. We dropped a level. Instead of having to read root 1, 2, 3 to get to Bob and then read the record 4, we dropped a level. So now we're only reading 1, 2, 3, found Bob, got the record Bob. So now we're doing one less read. So we're doing 4 instead of 5, and I've benchmarked this. Got exactly what I expected, a 20% performance gain. And that performance gain is real. So index compact your larger indexes when the utilization is less than 70%, and that will keep you, luckily, maybe you'll end up losing a level and you'll get that 20% gain. But if not, even more, you'll end up being able to find your index quicker, the key that you're looking for quicker.
Sorry. So what is the recommended index compact percentage?
That's a great question. By default, it's 80%. I say put it to 90%. I don't think 80% is enough.
But don't put it to.
Don't put it to 100. Okay, so if you put it to 100, you're immediately gonna split a block with the first crate that you do, right? So you don't want to do that. I like 90%. The default is 80, and then when you get below 70, time to do some maintenance. So how do you do the maintenance? Index rebuild, by default, is going to put it to 100%. You can specify lower, but index rebuild is kind of invasive. You have to run it offline, which means you have to turn off after imaging and OE replication if you're running it. And how it works is it scans everything and then puts it back in the index. Index compact is better. While it's not as easy as index rebuild all, there's no index compact all. It's table.index based, but you run it. It can be run online. That means that it runs with after imaging and it runs with OE replication, so you don't have to re-baseline if you're running OE replication. Scans the B tree, and it says what's your specified amount that you want. Default is 80. I'm going to read from the next block over and start cramming stuff into the current block till it hits 80% utilization, and then it's going to move to the next one and start filling in from the one in front of it until it goes through the whole B tree. Any questions on that? Gus has another quiz for me.
No, I have a suggestion. It's really simple to write some 4GL code that generates a script that compacts all your indexes.
Yes. Needs to specify each index, but it can be scripted very, very easily. For each underscore index, that's it. Display underscore index name. So now you have the index name and you're done. And you can associate the table with it, because you can go find the associated table with just a for each underscore table of index, and you're done. Good.
I think on Linux you can even do it with view v2 and grep.
Say that again.
You can do ProUtil view v2.
Yeah.
Yeah, and if we show you the structure.
Yeah, there's many ways. Grep, there's a lot of solutions to this, so it's very easily scripted. Okay, annual tasks. Perform a tune or a health check. So you've been sitting here, you own your system, you're looking at your system, and you know all about it. You're like, I got this. It's very cheap to have somebody else come in to come look at it, and you'd be surprised how often just another set of eyes, and you could be a genius. It's another set of eyes will be like, have you thought about this? And I will admit, having done this for a while, somebody will come in and look at something I'm doing and say, well, you're not doing that. I'm like, well, yeah, not really thought about that much. I've done this with other experts out there, and I've helped them. It's just you get blind to things. So for not a lot of money, you can have somebody else come in, take a look at your system, write a report, and maybe you'll get something out of it. So we had customers that were not on our managed program, but were on the annual health check. And what they got out of that was the first time they got 17 different recommendations. And then over time they implemented them. The second time that list of recommendations got down to 4. The third time that list of recommendations came out to 0. Did he get value out of it? He got incredible value out of it. He could then go to his management and say, look, I had a health check and we have an A. And that was money well spent. Nothing changed, but they felt confident that their system was running the way it should. Perform a dump and load if required, based upon the amount of scatter or fragmentation in the database. We'll talk about that. Archive and delete. This is the time, typically, annually, people, maybe around Christmas week or whatever, will try to archive stuff out of the database. If you do a massive archive out of the database, the next obvious thing to do would be to dump and load the tables that were affected. And then test your disaster recovery plan. Who's ever tested a disaster recovery plan? So about half the room. I'll be talking about this tomorrow, how people somehow think I'm their disaster recovery plan, and that's not the best plan. Things change. You need to have confidence in your disaster recovery plan. For the people that raised their hand, have they tested it more than once? Okay, some. So a performance tune. Here's some things. I'm just throwing some stuff out here. Things that people check on is buffer hit ratio, checkpoint duration, CPU utilization, latching, application tuning. That's what a health check typically does. And there's many companies that go and do a health check, based here in Europe, based in the US. I'm happy to do it remote without having people come on site. And what will they do? They'll change the memory allocation. They'll change the BI cluster size. They'll make recommendations for latch settings, and there's a host of things that they can recommend. And I think you'll be surprised. And some of them you're going to go, yeah, thank you for telling me that. I'm not going to do anything about it because it's not important to me. Let's talk about an example. I'm going to talk about an example of what the BI cluster size change would be, and how would you come to terms with that. So here's the Promon R&D 1-2 activity summary. And I'm highlighting the checkpoint screen. So this is a 10-second sample. It's a really small sample, and there were 2 checkpoints in that sample. I just happened to, find one of these, and that's a problem. That's something that should be addressed. So you go look in Promon R&D 3, 4 to get here, and this tells you all the checkpoints that you've had for a period of time. And you get the length and frequency, and those should be 60 seconds apart. These are 8 seconds apart, 2 seconds apart, 20 seconds apart. They should be 60 seconds apart. They should be 500 seconds apart. They should be as wide as you possibly can have these. So what is a checkpoint? Checkpoint is a periodic synchronization of the database in memory with the database on disk. You need to do it at some point. If you never did it, then when you shut down, all of those blocks would get written to disk at that point, and shutdown would take a long time. If you crashed, so you didn't shut down properly, the redo phase of crash recovery would take forever because you'd have to redo all the work that happened since the last checkpoint. So you need to checkpoint every periodic time to make sure that crash recovery and shutdown don't take forever. And here's some pictures as to how this works. So you have performance clusters on the left. You've got your database disk on the right. The database files are on disk, or blocks on disk, and then you have the buffer pool. And so you have the BI cluster has a block that says change block 10. The version of the block is going to go from 17 to 18, and the value of name is going to go from Mike to Don. So that's what gets spooled into the BI file. What's on disk is block number 10, version number 17, with the name Mike. It gets read into memory, and then the notes applied to it, and that version becomes 18, and the name becomes Don. So now we have an inconsistency. What's on disk and what's in memory is different. So that's got to get resolved somehow. How does it get resolved? As updates occur in this cluster, so it gets filled up. By the time it fills up that cluster, you have a lot of inconsistencies. You have a lot of blocks in memory that are no longer consistent with what's on disk. When that fills up, a chain is built called the checkpoint queue of all the modified blocks that exist in the buffer pool at that point in time, and then we move on. And now more changes are being made, more inconsistencies are being done on disk, but at the same time, you can see that the checkpoint queue is now trying to make the disk consistent. So part of the checkpoint queue, which points to blocks in shared memory, are now getting written to disk to bring those blocks to be consistent. And then by the time that fills up, hopefully the checkpoint queue is completely empty, and now you're consistent, not from that point in time, but you're consistent from the point in time from the previous cluster. And that's how checkpointing works. So here's some recommendations. This would be a recommendation that a health check would make to you. The default BI cluster size, I couldn't believe it, in 12.8 is still 512. I thought I heard that there was going to change in 12 to increase this. I can't believe it's still 512. That's way too low. I thought I changed the slide to not even say 4 megabytes and 8 megabytes. I thought I changed it to be 8 megabytes, 16 megabytes. But the values are, you can't just make the up in the air value. You can't listen to Mike and say, make your BI cluster size 128 megabytes or 64 megabytes. It doesn't work that way. But I can tell you it should not be 512. That's probably true. You need to test your disk speed. And the simplest way to test your disk speed is by doing this. I've never made a database that was not named X in my entire career. So ProDB X demo, I've never used sports because I've been at Progress for that long that we only had demo. So ProDB X demo, truncate the BI file and set the BI cluster size to 16 megabytes this way. And then time how long it takes to grow 2 clusters. This will give you 6 clusters. You get 4 by default, 2 more. 16 megabytes will make a 96 megabyte file. And what you want to do is to know how long that took. Take that time, divide 96 by the time, and that'll tell you how many megabytes per second you can that your disk write speed is, and then you can set your cluster size no larger than 2 times that speed. So if you've got a 6.3 megabyte cluster size, 6.3 megabyte per second disk speed, you can set your cluster size to 8. That's no more than 2. I wouldn't go to 16 because that's more than 2. You can set it to 12. It's not a power 2 number, but you can set it to 12. There's no reason why you can't. But you don't want to set it more than 2 times that, because if the BI file needs to grow, people are going to have a 2-second pause, which if your user base can typically tolerate a 2-second pause if it happens every 2 or 3 minutes. If you had a 10-second pause every 2 or 3 minutes, your phone would be ringing. 2-second pause every 2 to 10 minutes, they're probably used to that. That's okay. Yeah.
But also, if you grow your BI file, ADSC file, you will have pre-allocated space.
So there is the whole point of this BI grow command that I put in was to eliminate the pause. So you can game the system. You're like, okay, my disk speed is 6.2 megabytes per second, but I want to have a 16 megabyte cluster size. Well, that doesn't fit my 2 times rule. So you can pre-allocate your BI file before you start the database. You can pre-grow it and say, I'm going to pre-grow this to be 100 clusters. That'll make the BI file very large. And you'll end up working within that BI file, provided you don't have an unmonitored long-running transaction. You end up having the unmonitored long-running transaction, the BI file is going to grow because it needs to maintain that space. And as soon as it grows, now you're going to have that pause. And if that transaction continues, now you're going to have that pause for a periodic time.
And the BI grow, it still does format though that disk space, doesn't it?
The BI grow does format the disk space. If you're going to do it as part of your operation, use --little-case r only on the BI grow command. That's the only time I'm ever going to say to do that in production. Only on the BI grow command, because that'll make the BI grow command run quickly, as opposed to doing physical writes to the file. Or if you just take off the z extend sync IO, it'll do the same thing.
Doesn't it effectively do that in 1.3 and later?
Yes, without the z sync IO. Right. My timing's good. Okay, that was the presentation. So OpenEdge is easy, but it's not free. You still need to do some attention. It's not a full-time position unless you have a large deployment with many hundreds of users and terabytes of disk space. Typically, this is a job that you job share with some other role. A lot of our managed customers, when I was running the business, the people that were the business analyst people also were responsible for making sure the backups were there, right? So that they were doing the management of it. You cannot set it and forget it. It'll work for a while, but at some point it's not going to work. So it's not. You have to pay attention to some things. It'll work well for years. That's a fact, but it won't work well for decades. And a lot of these applications are decades old. And so I went through some things that you should be doing, periodically, and seek professional help. Again, have somebody come in annually. And if annually is too much, every other year, have somebody come in and take a look at your system and give you some recommendations. It doesn't cost a lot. This isn't, and I'm not trying to sell here. I don't work for the company anymore. I just know when I did, people that used our services to be able to have us look at the system, they got a lot of value out of it. Gus, you have a quiz question?
It's not a quiz question. So you mentioned a whole bunch of daily, weekly, monthly tasks. What's the most important task?
This is a quiz question. So he says, you mentioned daily, weekly, monthly, quarterly, annually tasks. What's the most important task? Making sure that your backups are testing your disaster recovery plan. What's your interpretation of this? Backups. Yeah, how many people have ever restored a backup? You know, I did this a long time ago in the U.S. I said, how many people do backups? The whole place, 150 people raised their hand. How many people ever restored a backup? About 3 people raised their hand. I'm like, well, why are you doing them? If you never restored a backup, why are you even doing them? So I'm glad that everybody's hand went up, that they at least restored a backup one time. It's important just to get the muscle memory of what that feels like. How to roll forward.
Make sure your backups work.
Yes. How to roll forward an after image file. I can't tell you how many DBAs, when they're under pressure, those commands just escape their mind. Make this routine. rfutile-c, a image, roll forward, -a, blah, 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 right? Just go. Script it. Yeah. Be careful with scripts for recovery. And I'll talk about that in my session tomorrow. So any questions at this point, besides Gus's quiz questions, unless he wants to ask more? Rob?
Just more an observation. I encounter a lot of people who are on a given release, whether it's current or not, and they don't even know all of the capabilities and features that are in the release they have. So yeah, you can upgrade and get more features and performance and so on, but a lot of people don't even know everything that their current release can do for them.
Yeah, so I'm going to repeat that because that comes back to the seek some professional help. So a lot of people are kind of tied to a release for whatever reason. Operating system could be a reason. They're the end user of an application partner. There could be many reasons why you're tied to a specific release. And there may be capabilities in that release that you're not aware of. Progress is upgrade, upgrade, upgrade. 11.7 is going away in April 1st. All this stuff, upgrade, 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 upgrade. Well, yeah, things are going to get better if you upgrade, but there may be capabilities in the release that you're on that you're not taking advantage of, and that's where the professional help could come in, because these guys know this stuff. That's their job, is they need to know what came in and what release and what makes sense for your environment. Fair?
Yeah. Or they're using hard-coded parameter values that are now lower than the default.
Yes, hard-coded parameter values that are lower than the new defaults, or using capital M lowercase f. I still see that sometimes. Take that out of any parameter file you have. Any questions? And I get that this was review for a lot of you. I appreciate you guys coming and supporting me. So thank you.